Hello students, this is a lecture series on the subject Operating System Design, first module. I am Seema Safar, Assistant Professor, Department of Computer Science and Engineering, Rajagiri School of Engineering and Technology. Let's begin the session. Now let's start with the evolution of operating system. Before that, let me ask you a question. What do you mean by an operating system? An operating system is a software that acts as an interface between the user and the machine. So here I have listed the evolution of operating systems starting from 1950s till 1990, which is listed as early systems, simple batch systems, multi-programmed batch systems, time sharing and real-time systems, personal or desktop computers, followed by multiprocessor systems, followed by networked or distributed systems, and finally web-based systems. Now let's see each one by one. Early system was a single user system where the programmers or the users acted as operators, and they made use of punched cards, and large machines were run from console. Here you can see a picture depicting a single user system, and on the topmost right side you can see a punch card. Here you can see an example of an early computer system, ENIAC. As you know, ENIAC, or Electronic Numerical Integrator and Computer, was the first electronic general purpose digital computer. Here you can see the programmers programming in ENIAC machine. Moving on to simple batch systems. Simple batch system made use of high-level languages or magnetic tapes. Here, jobs were batched together by type of languages, and as you can see in the figure, you can see an operator there sitting over there. An operator was hired to perform the repeated tasks of, he was actually responsible for performing tasks like loading jobs, starting the computer, and collecting the output. Next, we'll see memory layout for batch multiprogramming. As the name suggests, here several jobs are kept in main memory at the same time, and the CPU is actually multiplexed among them. This you can see in the figure on the right hand side. Now moving on to time sharing systems. Since the batch multiprogramming does not support interaction with the users, time sharing actually try to extend batch multiprogramming in order to handle multiple interactive jobs. So it is basically an interactive multiprogramming. Here, multiple users simultaneously access the system through commands entered at their terminals, and the processor's time was shared among multiple users. This is how the architecture of time sharing system looks like. In time sharing, actually the multitasking is being performed. That is, the CPU switches job so frequently that users can interact with each job while it is running, creating interactive computing. Alright, this you can see in the figure, where you can see a user interface through which the user interacts with the machine, and a device interface between between all the resources and the kernel, and a process interface between the kernel and the processors. Next, we have multiprocessor systems. This is an architecture of a multiprocessor system. Now, multiprocessor system, as the name suggests, is a system with several CPUs in close communication. So here the processors will be sharing memory as well as the clock, and the communication usually takes place through a shared memory, as you can see in the figure. Now, this is also known as parallel systems or tightly coupled systems. Now, usually multiprocessor systems will be having different advantages, like, they have increased throughput, they have increased reliability, and they have economy of scale, etc. Now, this figure shows you the difference in multiprogramming and multiprocessing. Figure A depicts multiprogramming and figure B depicts multiprocessing. Now, what do you understand from this figure? Multiprogramming is a technique to execute number of programs simultaneously by a single processor, which means in multiprogramming, number of processes are residing in main memory at a time. Now the duty of the operating system is to pick it and begin to execute one of the jobs in the main memory. Whereas in multiprocessor system, as you can see in the figure B, there is overlapping that is happening, which means multiprocessing system will be having several CPUs in close communication, and therefore it will be performing every operations in parallel. Now, multiprocessor systems can be categorized into two. It can be either asymmetric multiprocessing or it can be symmetric multiprocessing. Now, asymmetric multiprocessing is a case in which we have a master processor and a slave processors. Master processor is responsible for scheduling and allocating specific works to slave processors. Whereas in symmetric multiprocessing, each processor will be running an identical copy of the operating system. Typically, each processor does self-scheduling from the pool of available processors. Now, most modern operating systems support SMP or symmetric multiprocessing. Now let's discuss about clustered systems. It is just like multiprocessor systems, but multiple systems working together. Now, it is also known as closely coupled system. Now, which means this allows two or more systems to share external storage and balance CPU load. That is, the processor will be having their own external memory, and communication takes place through high-speed channels, and it will be providing high availability. Next, moving on to networked system. In network system, they are otherwise called as loosely coupled system. They distribute resources and the computation among several physical processors. They are called as loosely coupled system because each processor has its own local memory, and the processors will be communicating with one another through various communication lines. Now, the advantages of this system include resource sharing, computation speed up, and reliability. Distributed systems. As you can see in the figure. Now, distributed system is a collection of loosely coupled processors which is interconnected by a communication network. You can see a communication network there, and the processors are usually called as nodes or computers or machines or host. Now, the main reason for using distributed system is that they help in resource sharing and computation speed up and reliability in detecting and recovering from site failure, function transfer, etc. And the communication of the system is through message passing. Hope this is clear. Networked operating systems or NOS. Here each computer runs independently from other computers on the network. They'll be providing file sharing, and the users are aware of multiplicity of machines. Now, access to resources of various machines is done by remote logging into appropriate remote machine by using either Telnet or SSH, or they can use a remote desktop, or they can transfer data from remote machines to local machines via FTP mechanism. Moving on to distributed operating system. Here users are unaware of multiplicity of machines, and that is, they access to remote resources is similar to access to local ones. Now, network is almost transparent. It's like a powerful virtual machine here, and this contributes to three types of migration, namely data migration, computation migration, and process migration. Now, data migration in the sense that they transfer data by transferring entire file or transferring only those portions of the file necessary for the immediate task. Computation migration in the sense that they transfer the computation rather than the data across the system. Then we have process migration, which execute an entire process or parts of it at different sites. Now let's discuss about grid computing systems. They are a collection of computer resources which is usually owned by multiple parties and in multiple locations connected together such that users can share access to their combined power. So it can easily span a wide area network or a WAN, and it can be used in heterogeneous environment, and it is able to cross administrative or geographic boundaries, and it supports virtual organizations. Now, talking about cloud computing systems, they are basically a collection of computer resources usually owned by a single entity connected together such that users can access to share a very combined power, in the sense that they have a lot of advantages like location independence, where the user can access the desired service from anywhere in the world using any device with any system. All right, then they have cost effectiveness, where the whole infrastructure is owned by the provider and they require no, it is like, they don't require any capital overlay by the user. Then we have reliability. And another important thing is that security, which means low risk of data loss because of centralization, and it is readily consumable. We have a lot of examples like Amazon, Google App Engine, IBM Enterprise Data Center, Sun Cloud Computing, etc., etc. This figure finally depicts you migration of operating system concepts and feature, as we discussed. Please have a look at it. So by this we come to the end of this lecture session. So summary of today's topics covered include operating system, and we have discussed about different evolution of operating system, which included systems like early systems, simple batch system, and multi-program batch system, time sharing system, multi-processor systems, networked distributed system, and finally web-based systems. Thank you.